Small and insignificant, we sit on Earth and think we know everything about the vastness of the cosmos, just because we can illuminate a part of space with our tiny telescopes. Our computers calculate from data of the observations what is probably going on out there, physically and chemically. We reconstruct it from stories about star formation, the movements of bodies in space, and the beginning of the universe, and call it science. Then, a probe finally flies to where no man or technical device has ever been, and our probe sends data that may indicate something very big, and scientists wave it off. They don't want to know about a new force of nature that may have its own intelligence and be at home in the vast dark spaces of the cosmos. Voyager 1 and 2 are two of the most successful scientific space exploration vehicles ever created. Both probes have traveled incredibly far, seeing, photographing, measuring, and being the very first man-made objects to explore the far edges of the solar system. In 2012, the time had come. More than 30 years after its launch, Voyager 1 became the first to cross a magical threshold, the space where our sun's sphere of influence ends and the mysterious interstellar medium begins. The infinite darkness of space, the emptiness and silence that makes up 95% of the known cosmos, was touched for the first time by a human spacecraft. Who would have thought that Voyager 1 and 2 would experience this historic moment? What is beyond the Heliosphere? Were you aware that the space around Earth and all our neighboring planets is something very different from the gigantic empty space between stars? We always say a rocket flies into space, or we think outside the Earth's orbit begins the same space we see when Hubble and James Webb show pictures of the deep and dark black cosmos. But this is not true. All space from the Sun so far beyond the Kuiper Belt is affected by solar radiation and the magnetic forces of our star. Only many billions of kilometers away from the Sun, the real space, the void, the interstellar medium, begins. When exactly Voyager will finally reach this space was unclear for a long time. Researchers had expectations, but no facts, until Voyager provided them. It was suspected that the particle density would decrease sharply at some point. Where previously there were about 100 particles per cubic centimeter, there would then only be a few. At first, the measurement data of the probe surprised, since they indicated an increased magnetic force, which apparently still came far outside from the Sun and increased shortly before the crossing. Researchers concluded that there is a kind of stagnation of the solar force where it meets the interstellar medium. If both currents collide, the solar radiation forms something like a thick buffer. The researchers had not expected this. In 2015, the measurement data changed so significantly that interstellar space became more tangible. Everything went reasonably as predicted. Voyager 1 continued to function normally until mission scientists recently noticed that the probe suddenly seemed to have confused them about its position in space. NASA initially reassured that such an incident was to be expected at this stage of the Voyager mission. Suzanne Dode, project manager for Voyager 1 and its twin sister Voyager 2 at NASA's Jet Propulsion Laboratory in California, said the problem was most likely with the spacecraft's Altitude Articulation and Control System, or AACS, antenna alignment mechanism. But the AACS appears to be functional, as the spacecraft was receiving commands and sending science data back to Earth with the same signal strength as before. However, the telemetry data from the AACS was unassignable, even though the antenna had been properly pointed at all times. Otherwise, not a single signal would have reached us. According to NASA, staff took care to investigate the problem and fix it. But by then, some scientists had already begun to prick up their ears. They stumbled over the fact that Voyager 1 continued to send this supposedly meaningless data safely to Earth, and no alarm had triggered in the process, nor did the probe switch to safety mode. This may mean that the data was correct and that NASA simply could not interpret it correctly. Possibly, Voyager 1 encountered a structure in the interstellar space within which the normal data to space and time were no longer correct. On Earth, it looked as if the probe had not detected its position correctly, but in reality, we could be on the track of something unusual. An alien force or an alien signal? A short time after the strange confusion about its position in space, Voyager 1 caught something else that worried scientists. the particle detectors showed a faint plasma current where there should be nothing. Like a line, the current stretched through the supposed void, and scientists were once again worried. Explanations were quickly found, and officially, it was said that a small amount of superthermal electrons, which are generally present in plasmas, had produced a small plasma frequency peak on one of Voyager's short antennas. Most likely, it had been a small number of fast electrons. But again, other scientists did not agree. For them, all these strange measurement data speak one language, pointing to something mysterious. Plasma waves there where actually nothing should be, a loss of the space orientation, although Voyager actually functioned completely normally. All this speaks also for the fact that in the interstellar medium, a force prevails, which we do not know of so far. So researchers even dared to claim that this could be a new force of nature. They warned their colleagues not to take these measurement data lightly and to always want to explain everything immediately with what is known. If we really want to investigate the space between the stars, we must also be able to face new and previously unknown things. But neither NASA nor more conservative scientific circles want to know anything about this. Imagine you come to a new country. Before you have imagined how it would be there, perhaps you read a picture book or travel guide. Then many things are completely different there, and instead of surrendering to this adventure, you leaf through your books and compare the real events with your expectations. This is exactly what most researchers are doing right now with the exciting new discoveries of Voyager 1, and we may be missing out on important discoveries this way. Is NASA making a mistake? Instead of acting on new ideas, NASA released a new report on the fate of Voyager 1. Officials describe in detail how a dedicated team spent days digging through the probe's blueprints. Engineers had to sift through decades-old manuals to find a solution to the alleged problem. Some data was probably even taken home by long-retired engineers. Since both probes were only supposed to fly for 5 years, no one had thought that the data would become important again 40 years later. According to NASA, the Voyager team not only figured out the problem, but solved it. The statement goes on to say that we received tangled data before the spacecraft's Altitude Articulation and Control System, AACS, sent back information via an onboard computer that has been out of service for years. The data was deemed corrupted before it was even transmitted by the computer. Susan Dode's team instructed the AACS to resend its data through the spacecraft's working computer. After that, everything was back to normal. How long will we be able to accompany Voyager 1 and 2? The power generated by the two spacecraft is steadily declining, and mission team members have been turning off some components for years to conserve power. They hope the probes will remain in service until at least 2025. Voyager 1 is currently about 23.3 billion kilometers from Earth, or 156 times the Sun-Earth distance. The probes are tracked using NASA's Deep Space Network, which sends only 160 bits per second of data back to Earth. A typical home broadband connection is measured in megabytes per second, or millions of bits per second. Still, these transmission rates are enough to capture the measured data of the properties of the interstellar medium. After all, there must not be much there. Although Voyager 1 has soon flown 10 years beyond the Heliosphere, it has not yet completely left the solar system. Far out in space is another mystery of the nearby cosmos: the Oort cloud. This spherical disk of comets and asteroids is more than 2,000 Sun-Earth distances from the Sun. Although it lies far away from the actual plasmasphere of the Sun, the Oort cloud still belongs to our solar system. It's bound to our Sun by a mechanism that is not yet fully understood. It's probably the dent in gravity left by the solar system in space-time that binds this collection of asteroids and comets to us. Just imagine, Voyager 1 will need another 300 years or so to fly to this cloud. One day in the fall of 2023, everything suddenly changed. Voyager 1 sent a confusing combination of ones and zeros that made no sense. The cryptic message had to be decoded. Voyager 1 had already sent highly peculiar data from the interstellar medium to Earth twice before. Shortly after crossing into this largely empty space between the stars, the probe reported a mysterious plasma stream that should not actually exist there. Within the heliosphere, we still have around 100 particles per cubic centimeter. Outside the envelope of our solar sphere, scientists suspected only one particle in the same space. But on the one hand, Voyager 1 reported a fundamentally higher particle density than assumed, and on one particularly memorable day, the probe even recorded a veritable stream of particles. Plasma in the interstellar medium, where nothing should actually exist, is a mystery. Scientists therefore also suspected that the plasma could be a measurement error. Others were of the opinion that there may be more going on in the void of the cosmos than we previously thought. The third explanation was a stellar flare that somehow made it into the vacuum of space. This would mean that signals from stars can travel through the interstellar medium after all, but that would be rather unusual. Flares from our own sun only travel as far as the end of the heliosphere, which is about 100 astronomical units or 15 billion kilometers from the center of the solar system. Large streams of particles usually reach the threshold of interstellar space within a few hours. Since Voyager studied this area of the solar system, we have known that the streams of particles from the sun meet the interstellar medium there, and the pressure that the two exert on each other creates something like a thick shell. Without this important protection, the extreme radiation of open space would penetrate unhindered into the interior of the solar system, and life on Earth would probably not be possible at all. So not only do we have our sun to thank for warmth and light, our star also safely and reliably envelops us in a protective cosmic mantle. However, as the Voyager probes have shown us, the sun's plasma streams do not penetrate into interstellar space. They end strictly at the end of the heliosphere. So let's assume that the scientists are right when they say that the plasma stream came from another star. In that case, we have to realize that even the nearest star, Proxima Centauri, is more than 4 light-years away. This would mean that the plasma stream has traveled through the interstellar medium for more than 4 years, which is not possible. The plasma streams should actually be lost due to the low particle density in free space. If a current remains or makes it to the vicinity of our heliosphere, this current either originates from a nearby source or is driven by a very strong force. Whether the mysterious signal really comes from a star or a previously unknown natural force in the interstellar medium is still unclear. We would need further measurement data and observations to come to definite conclusions. This scientific surprise was followed by a shock. Voyager 1 suddenly sent such confusing data in 2021 that scientists thought the probe had lost its orientation in space. The error was corrected within a few weeks. The scientists discovered that the probe's telemetry data had shifted, making it appear as if the probe was tumbling uncontrollably in space. A system change brought relief, and Voyager 1 continued its grandiose flight through space. Voyager 1's unique journey. Something that many people don't realize is that NASA wasn't at all sure that Voyager 1 would ever even reach its first destination, Jupiter. The probe took a course that was considered difficult and risky by experts at the time. It took a direct route through the asteroid belt between Jupiter and Mars, while Voyager 2 chose a slightly different route and performed several acceleration maneuvers at various planets. Their route was considered safer, and 2 probes had been specially constructed so that they would have another one in case one of them was lost. In the 1970s, a constellation of the outer planets took place that only occurs once every 176 years. NASA had to take advantage of this, and at least one probe was to reach the outer reaches of the solar system. The world was lucky because both probes arrived exactly where the scientists wanted them to be. In March 1979, and only 18 months after launch, Voyager 1 was already at Jupiter. That was sensational. During its approach and flyby, it provided breathtaking images and valuable data of Jupiter's turbulent atmospheric currents and powerful storms. It photographed the red spot and the colorful cloud bands. Io, Jupiter's moon, had long been known at the time. As one of the largest moons in the solar system, Io was already visible with fairly simple telescopes in the late Middle Ages. What was completely new in the 1970s, however, was the discovery of volcanic activity on the moon. Nobody had expected to see sulfurous volcanic eruptions shooting kilometers into space on a moon. It was the first direct observation of geological processes on another body in the solar system, and thus a milestone in planetary research. While Voyager 1 was making all these fantastic discoveries, Voyager 2 was already on its way. It reached Jupiter in July 1979 and initially confirmed many of the discoveries made by Voyager 1. In addition, there were further surprises and detailed observations of the rings and numerous moons of the gas giant. The two probes worked hand in hand to complete our understanding of the largest planet in our solar system and its moons. After the successful flyby of Jupiter, Voyager 1 continued its journey and reached Saturn in November 1980, where it was the first to photograph the planet's rings up close, finding evidence of complex structures within the rings and observing Saturn's atmosphere and magnetic field. Special attention was paid to Titan, Saturn's largest moon, whose dense, foggy atmosphere triggered speculation about a possible resemblance to Earth. Here too, the two probes worked together brilliantly. Voyager 2 reached Saturn in August 1981 and supplemented the studies on Saturn. Among other things, its data served to clarify questions that had arisen after Voyager 1's visit. Voyager 2 then continued its mission by flying on to Uranus and Neptune, while Voyager 1 embarked on an orbit that would take it directly to the end of the solar system. A particularly memorable moment in Voyager 1's mission was when the image of the pale blue dot was taken. This image gives the impression that the most successful and furthest traveled probe of all time is looking back at its starting point, Earth. Our blue home appears in the picture as a tiny, fragile blue dot in the vast ocean of space, and yet the probe was only around 6 billion kilometers away from Earth in 1990, the year the picture was taken. In cosmic terms, that is a stone's throw, but for us, it was a milestone. This image shows us how insignificant our planet is in the vastness of the universe. It's not much more than a grain of sand on a beach, and yet our world is so rich and so beautiful. The picture was taken at the suggestion of Carl Sagan. Sagan was an astronomer who spent his life pointing out what a unique treasure our little world is. Finally, in August 2012, Voyager 1 became the first man-made object to cross the threshold into the interstellar medium, leaving our solar neighborhood and entering a region where the influences of the Sun are gradually being eclipsed by the influences of the galaxy as a whole. Voyager 1 provided almost 12 years of invaluable data, but then something happened again that now very probably means the end of the probe. A sad farewell to Voyager 1. NASA had wanted to avoid this. All the technicians, scientists, and control staff were proud and happy when the telemetry problem was successfully resolved in 2021. When the next shock came in the fall of 2023, everyone was initially optimistic. Voyager 1 was transmitting a jumble of ones and zeros, and the data no longer made sense. A technician from the Deep Space Network, through which Voyager 1 communicates with Earth, decoded the message as an imprint of the internal storage system, where a simple computer records all the probe's data and movements. The database could be described as a kind of universal logbook, and at the same time, it also contains the complete control of the probe. The probe is therefore still alive and probably largely functional. Only the transmission of the data no longer works. Unfortunately, the problem turned out to be difficult this time. So far, NASA has not found a solution and is very skeptical that the problem can be solved. Now we have to expect the worst, and the Voyager 1 mission may now be over, at least as far as our communication with it is concerned. The probe will continue to fly, but we will no longer be able to track it. During a routine check, NASA's control team had inadvertently sent an erroneous command to Voyager 2, causing the spacecraft to turn its communications antenna away from Earth. Given the enormous distance of over 18 billion kilometers, correcting this error was a monumental challenge. Each signal from Earth took more than 17 hours to reach the probe, and it took just as long for a response to arrive back on Earth. Days went by without a signal being received, adding to the concern. A permanent loss of communication with Voyager 2 would not only have meant the loss of a historic mission, but also the loss of an invaluable source of data about interstellar space. In a last-ditch effort to re-establish communications, the NASA team sent a series of commands in the hope that Voyager 2 would receive one of them and respond accordingly. It was a race against time, as the probe's power supply and ability to receive commands diminished with each passing day. At the same time, every day that this probe sends data from space is valuable to the scientists. The sweating and worrying continued into August 2023. Some scientists had already given up hope, and NASA had to seriously consider publicly announcing the loss of the probe. Then the unbelievable happened. Voyager 2 responded again. The signal was weak but unmistakable and was a clear sign that the probe had received the command and carried it out correctly. The relief and joy in the control center were boundless. The NASA team had achieved the seemingly impossible. Communication had been re-established with one of the most distant man-made objects in the universe. This meant that Voyager 2 had also successfully overcome a crisis. In 2022, after more than 45 years, the sister probe Voyager 1 found itself in an awkward situation. The telemetry data was no longer correct, and for a few days it seemed as if the probe had lost its orientation in space. But here too, NASA showed itself to be in control. After weeks of troubleshooting, those responsible discovered a fault in the onboard computer. Here too, the engineers delivered a brilliant performance. Similar to Voyager 2, they sent an instruction over 20 billion kilometers. The probe changed the onboard computer system, and after hours of hoping, a response finally came back. How long these two veterans of space exploration will continue to send data is unclear. However, the scientists hope to be able to maintain contact with both Voyagers until around 2030. Then they will disappear forever into the depths of space and radio contact will be lost due to a lack of power. Voyager 2 at the magical threshold of the Heliosphere. The scientists had imagined everything in detail. For decades, there were concrete ideas of what it would look like at the end of our solar system. Computer simulations calculated everything precisely, and then the surprise happened. On November 5th, 2018, Voyager 2 approached the magic boundary of the solar system. The researchers noticed that the probe was unerringly approaching this threshold by, among other things, a change in the ambient radiation and particle density. No one had ever seen this threshold, and no probe had ever been there before. What would Voyager 2 find there, billions of kilometers from Earth? Naturally, the researchers hoped that the probe would confirm their data and calculations. But then came the disappointment. Voyager 2 reported completely unexpected data. This repeated the unpleasant truth for the scientists, as Voyager 1, the twin probe, had already traveled across this distant threshold in 2012 and had transmitted similar data. Neither probe confirmed the researchers' assumptions. The heliosphere does not end gently like a beach, but more like a wall or an invisible bulwark. That was surprising. Ever since Voyager 1 had sent this data, there had been confusion. Had the probe perhaps traveled across the threshold at a particular point that was structured differently? No, after Voyager 2 transmitted almost exactly the same impressions and measurement data, it was clear that the sill of the solar bubble is quite solid and bumpy everywhere. This groundbreaking discovery once again proved to our scientific community that we can't know anything for sure until we, or probes, have been there. It confirmed once again that we know very little about the universe for sure, and that theories are just theories, not truths. Our universe is unimaginably large and contains countless phenomena, objects, structures, and peculiarities, very few of which we can visit or examine on site. We have to rely on model calculations and hypotheses, and these are often wrong, as the Voyagers proved once again. The day Voyager 2 flew over the threshold of the Heliosphere was another moment when a piece of the puzzle fell into place in our cosmological worldview. Now, knowing for sure how our solar sphere ends brings more clarity, but also new questions. Just the question of how the hard threshold at the end of the solar bubble is formed will keep researchers busy for several years. Scientists spontaneously explain this with the interaction between the solar wind and the interstellar medium. Presumably, the pressure of the interstellar space causes streams of particles to pile up at the edge of the solar sphere, which then form an almost solid threshold or a dense outer skin. However, this means that the interstellar medium has a different structure than we previously thought, and the probes actually delivered surprising measurement data here too. There are far more particles in interstellar space than previously assumed. You can imagine the heliosphere as a huge bubble. This bubble is formed and maintained by the constant solar wind. The sun envelops itself and its planets in this protective balloon of particles. The main difference between the heliosphere and interstellar space is its density and temperature. At the outer edge of this sphere, the two media meet and an interaction occurs. This outer edge is the heliopause, and it extends between 10 and 20 billion kilometers from the sun. In total, the heliosphere has a diameter of around 30 billion kilometers. This structure in which we live is not static. The entire sphere travels as a closed unit through the galaxy and the universe. The solar system is located in one of the outer spiral arms of the Milky Way. We are probably moving through the galaxy here in our bubble at 828,000 kilometers per hour, and our galaxy is moving through the universe at around 2.1 million kilometers per hour. 1977 was perfect for the start. At the beginning of the 1970s, a researcher happened to recognize a special constellation of planets and had an idea. Soon the outer planets would be lined up as perfectly as they are every 176 years. During their orbits around the Sun, Jupiter, Saturn, Uranus, and Neptune could be in completely different quadrants of the system. But during this constellation, all four should be almost in a row close to each other, so that a probe could easily reach all four planets. The constellation also brought the planets so close to Earth that the flight time to Neptune was a whole 12 years shorter. NASA had to seize this opportunity. Two simple and almost identical probes were constructed in a rush. Voyager 1 and 2 got by on a minimal budget and were launched at record speed. On August 20th, 1977 and September 5th, 1977, Voyager 1 and 2 were launched on board Titan Centaur rockets on their iconic journey into space. Little did anyone know at the time that more than 45 years later, these two probes would still be flying through space, breaking record after record. After passing Jupiter and Saturn, Voyager 2 used the gravitational pull of the two planets to perform a gravitational maneuver that took it to Uranus and Neptune. For the first time, humans saw bright blue Uranus in all its beauty, and Voyager 2 photographed deep blue Neptune in all its splendor for the first time. In addition to the images, Voyager 2 provided groundbreaking measurement data. The probe showed the wafer-thin rings around Uranus for the first time, photographed the most violent storms in the solar system on Neptune, and discovered previously unknown moons of the two ice giants. These were historic moments for science and humanity. When will Voyager 2 reach the nearest star? Voyager 2 will travel through complete darkness for another 40,000 years or so, then a light will appear again for the first time. It will probably be Ross 248. Computer calculations have shown that the probe's course will take it directly there, but it's unclear whether the probe will be captured by this system. The probe is probably too small and too light to enter the sphere of another star. Voyager 2 will therefore remain in the interstellar medium and fly on, until after thousands of years the next star passes by. Nobody knows how long these probes will continue their journey through space. They may simply break apart at some point, or they may still be flying millions of years from now. We humans are optimists. Just in case there is life out there in space somewhere, we have attached a calling card of our civilization to the two Voyagers. Should aliens ever get their hands on the probes, they will find two golden records and a simple set of instructions inside. Designers and scientists have created the records and the mechanism in such a way that any technologized species should be able to play the discs. Now, we don't know who or what is out there in space. The discs could also end up in a world where there are only animals or plants. Voyager 1 is so far out in space that it is almost 6,000 times the average distance from the Earth to the Moon. More than 45 years have passed since the space probe set off on its iconic mission in 1977, and the probe and its identical twin, Voyager 2, have explored areas where no man-made object has gone before. Voyager 1 was the first human probe to reach Jupiter in March 1979. There, it took the first detailed images of Jupiter's turbulent atmospheric patterns, including the Great Red Spot, and provided fascinating insights into the diversity and activity of its moons. Since then, we have known about volcanic eruptions on Io, and we had the first evidence of subsurface oceans on Europa. After the successful exploration of Jupiter, Voyager 1 flew on to Saturn. The probe mapped Saturn's impressive ring systems and discovered the fine structures within the rings. It also took the first close-up image of Titan, Saturn's largest moon, and revealed important data about its dense atmosphere, prompting scientific speculation about Earth-like fluid cycles on the moon. After these groundbreaking discoveries, Voyager 1 continued its journey past the outer planets on a path that would eventually take it out of the Sun's sphere of influence and into interstellar space. That was in 1980. The probe then flew through the Kuiper Belt for 10 years before finally reaching the magical threshold of open space after another 12 years. On August 25, 2012, Voyager 1 was clearly visible in interstellar space for the first time, and there were some surprises waiting for the researchers. Signals so strange they shouldn't exist. What was really going on when Voyager 1 measured a sudden stream of particles in interstellar space? Particle streams in open space should not actually be so close to our solar system. Scientists suspected that the stream could have originated from a distant event, such as a plasma ejection from a star. However, it would be highly unusual for such streams to travel so far into interstellar space and be carried so far by it. You must realize that the closest star to the location where the mysterious stream was measured is more than 4 light-years, or 37,842,921,890,333 kilometers away. A plasma ejection stream at this distance should have long since dispersed within the emptiness of the universe. Many scientists therefore doubt the theory and concede that we could be dealing with a mysterious, unknown force. Some daring scientists have even speculated that the particle stream could indicate activity from extraterrestrial life forms. Surprisingly, Voyager 1 showed that the overall particle distribution in space is much denser than previously thought. This may not sound very exciting at first, but in astrophysics, just a few particles can change our entire picture of the universe. One of the most striking features of interstellar space is the significant increase in cosmic rays. As expected, Voyager 1 recorded a significant increase in the intensity of cosmic rays. This observation provided important information about the composition and dynamics of space beyond our heliosphere for the very first time in human history. The data from Voyager 1 also indicate that the interstellar magnetic field is stronger and has a slightly different orientation than expected. These findings are not only forcing scientists to rethink their models of the interstellar medium and the interaction between the solar wind and the interstellar medium, we may have to rethink the entire math of our galaxy. The magnetic fields in the interstellar medium play a crucial role in the dynamics of galaxy assembly and star formation. Some theories even suggest that the magnetic fields could also be remnants of a primordial magnetic field that emerged shortly after the Big Bang. These original fields could therefore still be magically effective primordial structures that carry the developmental processes of the entire universe within them and are therefore messengers of cosmic history. Why is Voyager 1 so long-lived? It was a memorable day in human history when a Titan 3E Centaur rocket launched Voyager 1 into space on September 5, 1977. No one thought it would be more than 45 years in the future. At the time, the scientists wanted to take advantage of a unique conjunction of the outer planets, which only occurs every 176 years, to send the Voyager probes to the then still largely unknown planets. The first target was the gas giant Jupiter. Voyager 1 arrived there a little earlier, although it was launched later than its sister. This was because Voyager 1 had taken the more direct, but also more dangerous course through the asteroid belt between Mars and Jupiter, while Voyager 2 was accelerated along slightly different orbits. Both Voyagers also stopped by at Saturn, after which they parted ways. While Voyager 1 set a direct course for the end of our solar system, Voyager 2 delivered the very first images of the planets Uranus and Neptune. The scientific and technical successes of the probes in the 1980s were already overwhelming. The fact that Voyager 1 is still functioning and transmitting scientific data well over 45 years after its launch is nothing short of a miracle. The Voyager mission was an open-ended adventure. At the time, NASA was already planning a further flight into the Kuiper Belt and possibly even further, but whether the probes would actually arrive was written in the stars. The fact that both probes reached open space is an iconic achievement, and they could continue to deliver important data for some time. If something hadn't happened, that scared NASA. Is Voyager 1 about to end? It was the nightmare no one wanted to experience. In the middle of one of the most exciting phases of the mission, Voyager 1 reported a disaster. In May 2021, it looked as if Voyager 1 had completely lost its orientation in space. But then, the engineers noticed that although the probe's signal was going crazy, it was surprisingly consistent. If Voyager 1 were tumbling around in space, The signal would arrive with interruptions because the probe's antenna must always be pointed strictly towards Earth in order to transmit the signal over the long distance. If the signal arrives, the antenna must also be correctly aligned, and consequently the position of the probe in space must still be stable. So where did the crazy telemetry data come from? For weeks there was confusion. Signals were coming in, but they made no sense. The mood at NASA was one of crisis. Dozens of engineers set to work, studying old construction plans from the 1970s, bringing long-retired technical staff out of retirement, and finally a solution was found. Telemetry data is essential for monitoring and controlling spacecraft, as it provides information on the status and health of the various systems and instruments on board. An analysis showed that the faulty telemetry data came from the attitude, articulation, and control system, which is responsible for pointing the spacecraft in space. As the antenna was correctly aligned, the program of the control system must have somehow got mixed up. It was agreed that the AACS may have started sending telemetry data over a path or channel not intended for it, which then led to the illogical data. The challenge was to fix the problem from billions of kilometers away. One wrong instruction could have made the problem worse and rendered the probe useless forever. The team worked feverishly to find a solution and decided to reroute the internal controls to an alternative system to see if it would work again from there. As you can imagine, the tension was high. The order was sent from the control center in California. Engineers had to wait 20 tense hours for Voyager's response. Then came the relief. The plan had been a complete success and Voyager was sending usable data again. Then came another shock in the fall of 2023. Once again, confused data arrived at the control center in California. Of course, the incident was immediately reminiscent of the problems from 2021, but something was different. The communication disruption occurred for the first time on November 14, 2023. Instead of normal radio contact, the probe transmitted a meaningless, repetitive sequence of zeros and ones. NASA suspects a malfunction in the Flight Data System, FDS, which is responsible for collecting and transmitting data from the scientific instruments and status information from the probe. Experts have been tasked with deciphering the cryptic data. It was hoped that the data could be used to draw conclusions about the error, and they succeeded. An engineer from the D-Space network, over which Voyager 1's signals are transmitted, discovered that the jumble of ones and zeros was an exact replica of the probe's FDS memory. So Voyager 1 was still alive, only the data was acting up again. Despite the glitch, the probe was able to receive and execute commands from Earth, further indicating that not all communications capability was affected. At the time of the video's release, the problem still persists. Due to the long distances and software limitations, diagnosing and repairing the problem is again complicated. So far, there is uncertainty as to how the fault could be fixed this time. In NASA's latest statement, the head of the Voyager project, Suzanne Dodd, was not very hopeful. NASA is expecting the mission to end prematurely, further into space than ever before. It's magical. The solution to the problem will give us years more of data from a space that has not yet been explored. Voyager offers us the unique opportunity to receive measurement data from the infinite space between the stars and planetary systems for the first time. The Voyager mission is truly one of the boldest space exploration missions we humans have ever launched. The primary scientific objectives of the Voyager mission in the near future include the ongoing study of interstellar space. Voyager 1 and its sister ship Voyager 2 are the only man-made objects that have ever ventured into this unexplored realm. The further away the probes are from Earth, the more exciting but also the more difficult the mission becomes. It is already a miracle that we can maintain contact with technical devices that are so far away. The second critical point is the energy supply. The plutonium-based radioisotope generators on board the probes produce less and less energy over time. The mission teams have already switched off most of the instruments in order to reserve the remaining energy for the most important scientific missions. NASA is currently hoping that both Voyager probes will continue to transmit data until the end of the decade and possibly beyond. But even when the radio link has long since been lost, the mission will not end. The Voyager twins will then become ambassadors for our civilization and culture. Each probe is equipped with an extremely long-lasting golden record on board, which contains sounds, images, and messages from Earth. In many thousands of years, the probes may be captured by the gravitational pull of a star and then appear on the radar screens of another civilization. Voyager. Fast, cheap, reliable. It's hard to believe, but these two veterans of space exploration were put together in a few months on a mini budget to take advantage of a special window in the constellation of the outer planets. Saturn, Jupiter, Uranus, and Neptune had not been so favorably aligned for 170 years, and it was known in the 70s that it would take another 170 years for the four outer planets to come together again. So they took action and built the two Voyager probes in a rush. Both were to take slightly different courses, and if one was lost, the other would still have been there. In the end, both reached their destination. 1977 was the beginning of an epic journey. To increase their speed, both probes flew several maneuvers around planets. Voyager 2, launched on August 20th, 1977, reached Jupiter on July 9th, 1979. Voyager 1, which followed on September 5th of the same year, reached Jupiter in March 1979 and provided the first breathtaking images and valuable data about the giant planet and its moons. One of the most remarkable results was the discovery of volcanic activity on the moon Io. At the time, this was the first observation of volcanism outside the Earth. After the successful flyby of Jupiter, Voyager 1 continued its journey and reached Saturn in November 1980, revealing the complex structure and beauty of Saturn's rings and providing fascinating insights into the planet's atmosphere and moons, as well as the first detailed look at Titan, Saturn's largest moon. Voyager 2 investigated the aspects around Jupiter that Voyager 1 had missed. Together, the two provided a perfect picture of the gas giant and so many images that scientists still rave about today. Voyager 2 visited Saturn and continued its unique journey to Uranus and Neptune. During its flyby of Uranus in January 1986, Voyager 2 discovered 10 new moons and 2 new rings around the ice giant. The journey culminated in August 1989, when Voyager 2 became the first probe to fly past Neptune and send us the very first image of the planet. Voyager 2 discovered Neptune's Great Dark Spot, many clues to the most violent storms in the solar system, and previously unknown moons. After providing invaluable insights into the outer planets, the Voyager probes continued their journey beyond the confines of the known solar system. Their mission was extended to an interstellar mission, and NASA was amazed at the tenacity and reliability these two simple probes had shown up to that point. No one had initially hoped that the two would eventually reach the boundaries of the solar system, but they did, and researchers are very grateful for these moving moments. The first time in the Heliosphere. It was a cause for celebration. Voyager 1 reached the Heliosphere in August 2012. The enormous bubble in interstellar space created by the solar wind, the stream of charged particles emitted by the sun, envelops our solar system and protects it from cosmic radiation. The boundary of the heliosphere, where the solar wind meets the interstellar medium and loses velocity, is called the heliopause. Beyond this boundary, the influence of interstellar space begins. Compared to the incredible vastness of the universe, the heliosphere is only a tiny dot. However, it extends far beyond the outermost planets of our solar system. Voyager 1 was the first probe to cross the heliopause and entered interstellar space in 2012, about 121 astronomical units away from the Sun, the equivalent of around 18 billion kilometers. Although this is an enormous distance from our point of view, it's small compared to the size of our galaxy. The Milky Way has a diameter of around 100,000 light-years, which corresponds to 6,324,107,700 astronomical units. And our Milky Way is only an average-sized galaxy in a universe that is home to billions of galaxies. So the threshold of the heliosphere is really only a pebble's throw in cosmic terms. But for our science, it was a huge breakthrough that revealed some surprises. Expected results were the decreases in the solar wind and the increase in cosmic rays from outside our solar system. Unexpected, however, was the discovery that the magnetic field outside the heliosphere was stronger and oriented differently than predicted. Voyager 1 encountered a magnetic field that is more than 10 times stronger than the magnetic field inside the heliosphere. This discovery confronts us with completely new questions about the structure of the interstellar space and the interaction between the solar wind and the interstellar medium. Another unexpected result was the discovery of a magnetic highway at the boundary of the heliosphere. In this region, charged particles flow back and forth between the heliosphere and interstellar space, indicating a more complex structure of the heliosphere than previously thought. Imagine a probe the size of a VW Golf flying past a spaceship. The occupants of the spaceship would probably be surprised. Then they would capture the strange object and examine it. In the belly of the vehicle, these beings find a small golden disc with an instruction manual that shows in small pictures without words how to play these parts. The aliens soon hear sounds from an alien world, things we would describe as the sound of the sea and birdsong, human laughter and cars. When the aliens look even further, they find evidence of the DNA of the beings who built this vehicle. They are astonished to discover that it's not so dissimilar to their own. In the onboard computers, the extraterrestrial scientists find records of where this probe came from, the route it took, and everything it saw along the way. It soon becomes clear that this object has been traveling for thousands of years. It comes from a planet called Earth, and the vehicle, which is apparently a space probe, was the first scientific measuring station to explore the end of the solar system where its builders lived. 2018, a quick farewell to the heliosphere. Perhaps at some point in the distant future, some beings will share what we humans were able to learn from this probe on November 5th, 2018. On this day, Voyager 2 reached a significant milestone in human space exploration. When the probe left the heliosphere and entered interstellar space, it became the second man-made object to accomplish this feat. Voyager 2's transition astonished researchers on Earth primarily because of the sharp boundary. The data indicated an abrupt transition from the heliosphere to the interstellar medium, which no one had expected up to that point. There were model calculations and assumptions as to what this boundary would look like. But it's only since the Voyager probes visited this place that we really know what is going on there. The heliosphere is a large protective bubble formed by the continuous stream of particles from the Sun. It extends from the Sun far out into the cosmos. It was clear that this sphere of influence would end somewhere, but researchers did not know exactly where or how. It was assumed that the heliosphere would slowly run out, like on a beach. But in fact, the sphere of influence of our star ends very abruptly, more like a solid wall. Voyager 2 discovered another interesting feature of this threshold. A kind of magnetism seems to reduce the penetration of energy, electrically charged particles from interstellar space many billions of kilometers away from us. At the threshold where the pressure of the dense, hot solar wind meets the thinner and cooler interstellar medium, a solid boundary is formed. It is almost as if our solar system really were encased in a solid sphere. This idea fascinates researchers and observers of the mission alike. Voyager 1 already passed this magical boundary of the heliosphere in 2012 at almost the same distance from the Sun, which further indicates a uniform shape of the heliosphere. Somehow, it's a nice thought that our world and our entire solar system are embedded in a protective ball. Of course, the very first measurements beyond this magical boundary were also eagerly awaited. The interstellar medium fills the area between the star systems. Up until this point, it was just as much a mystery to us humans as the boundary of the heliosphere. The first surprise came in the form of the temperatures in this space. At 30,000 to 50,000 Kelvin, the values were significantly higher than the expected 15,000 to 30,000 Kelvin. The medium most likely consists of radiation, magnetic fields, and particles from the Big Bang and the first stellar explosions. These waves and particles have been traveling through the cosmos for billions of years. Sometimes they encounter star-forming regions where they become part of new stars. They are attracted or repelled by solar systems and continue to fly through space, just like our two Voyager probes. The data from Voyager 1 and 2 showed many similarities, but also some significant differences that raise new questions about this fringe region. The interstellar magnetic field is about 2 to 3 times stronger than expected, which means that the interstellar particles exert up to 10 times more pressure on our heliosphere than previously thought. This raises questions about the dynamics of our solar system, which is moving through the interstellar medium at a speed of about 828,000 kilometers per hour, or about 230 kilometers per second. Pasadena, we have a problem. It must have sounded a bit like the famous radio message from the Apollo 13 mission, when the engineer on duty in the early 1970s informed his superiors that something had gone very wrong on the third manned flight to the moon. Only this time, it wasn't an Apollo space shuttle reporting problems, and the control center wasn't in Houston, but in Pasadena, California. The situation wasn't quite as tricky, because in 1972, 3 lives were at stake, and in 2019, it was just a probe made of steel and circuitry that went haywire. Nevertheless, the confusing data that Voyager was suddenly sending was received with great concern. No one wanted to lose the probe at this crucial point in the mission. What had happened? Apparently, the Voyager 1 probe had lost its orientation shortly after entering the interstellar medium. There was no explanation for completely crazy telemetry data. On the one hand, the data showed that the probe was simultaneously in a stable orientation and in a state of disorientation. The 2 Voyager probes had already experienced several technical anomalies during their long journey through the solar system, but this was new. After weeks of searching, NASA officials realized that the attitude articulation and control system had apparently received confusing data from one of the onboard computers. To track down the error, the scientists and technicians spent hours digging through NASA's archives, searching for construction plans from the 1970s and asking long-retired engineers for advice. Repairing a probe over a distance was a completely new challenge for NASA, but it worked. When the error in the onboard computer was corrected, Voyager 1 knew where it was in space again and continued its mission. NASA breathed a sigh of relief. Of course, it's nothing short of a miracle that these 2 probes are still in full working order. They have been exposed to the extreme conditions in space for more than 45 years. The radiation, the extreme temperatures, and the long operating time have certainly led to a number of signs of wear and tear. The probes are already functioning well beyond their original mission duration, and now that they are finally in the interstellar medium, NASA is keen to keep them functioning for as long as possible. Such an opportunity to obtain measurement data from these areas will not come again so quickly. Marvels of technology. Did you know that the Voyager probes were assembled in a rush and on a shoestring budget? No one thought at the time that these simple probes would become the pioneers and heroes of interstellar exploration. Voyager 1 and 2 are equipped with a variety of scientific instruments that enabled them to carry out their missions within the solar system and now beyond. One of the key instruments on board is the magnetometer, which is used to measure the strength and direction of magnetic fields. This instrument has been crucial in detecting the abrupt changes in magnetic alignment during entry into interstellar space. The mag data has shown that the interstellar magnetic field is much stronger than expected. Another important instrument is the low-energy charged particle instrument, which measures the energy and direction of flight of charged particles. This instrument has been instrumental in understanding the composition of the solar wind and the interactions between the solar wind and the interstellar medium. It has also helped us to explore the structure of the heliosphere and the dynamics of its boundary. The Plasma Science Instrument, PLS, measures the properties of the solar wind plasma. The PLS data provided details about the density, temperature, and velocity of the solar wind and the changes at the transition to the interstellar medium. The cosmic ray system on board the Voyager spacecraft measures the composition and movement of cosmic rays in interstellar space. These measurements have shown that the intensity of cosmic rays in interstellar space is higher than in the heliosphere, which has been interpreted by scientists as evidence of the protective effect of the heliosphere against cosmic rays. Finally, the Voyager probes also have an ultraviolet spectrometer that can measure ultraviolet radiation from stars and the interstellar medium. Thanks to this instrument, we will be able to investigate the composition and physical properties of the interstellar medium for some time to come. The 2 probes will probably remain fully functional until 2025, when the energy reserves of the nuclear batteries inside the probes will come to an end, and Voyager 1 and 2 will gradually run out of power. The probes will still continue to fly, but they will no longer be able to send measurement data. Is the interstellar medium inhabited? Would you believe me if I told you that the interstellar medium is home to living beings? Probably not. Nevertheless, this theory exists, and it's based on measurement data from Voyager 1. That sounds crazy, doesn't it? But let's take a closer look at how some space enthusiasts and borderline scientists came up with this idea. But first, let's take a look at what the interstellar medium, or ISM for short, actually is. Broadly speaking, the ISM is the stuff that fills the space between the stars. This medium is most likely 99% a mixture of gases, such as hydrogen and helium, and dust particles that make up the remaining 1%. Although the ISM looks like a large void, it is a substance, a structure, and is probably very complex and varied. The density in this space is surprisingly low, averaging 1 atom per cubic centimeter. For this reason, the medium cannot transport sound, and other waves and radiation also travel completely differently here than within our heliosphere and within the atmosphere of a planet. The temperatures in the ISM are also very different. They range from a few freezing Kelvin in dense molecular clouds to a scorching millions of Kelvin in ionized regions. These extreme conditions create cosmic phenomena that scientists would like to know more about. Voyager 2 has shown that the interstellar medium near our solar system has a higher temperature and a stronger magnetic field strength than previously thought. Despite these new measurements and advances, the ISM still remains a big mystery. Interactions between different regions of the ISM probably also play a role in star formation and the overall movements of stars through the galaxy. But now to the alien theory. Voyager 1 suddenly emitted a dramatic increase in particles from the interstellar medium. It was a bit like when a dense signature of something unknown suddenly appears in an almost empty space. Or imagine a diver in the ocean suddenly spotting a strangely dense shoal. He would become curious and want to know what it is. Possibly a current, a school of fish, or an unknown creature? Some researchers who analyzed this data felt the same way. The sudden increase in particles and their signature didn't look like anything randomly blowing through the ISM. It looked more like a special force, a mysterious form of energy, or even a living being. That is why some researchers came up with the idea that it could be something living that is at home in the ISM, or a previously unknown natural force. These assumptions have not yet been confirmed, but we can look forward to seeing what the Voyager probes will show us in the remaining years of the mission. If you love exciting videos about space, subscribe to our channel now.